A circle with centre C minus 3, 2 has this equation. Find the y-coordinates of the points where the circle crosses the y-axis. Find the radius of the circle. The point P2, 5 lies outside the circle. Find the length of CP, giving your answer in the form of root n, where n is an integer. The point Q lies on the circle so that PQ is a tangent to the circle. Find the length of PQ. So that's the question, then I've paraphrased it here. Okay, let's have a look at this then. I would like to write this in standard form, but that's not really the way the question is leading us in, because it says find the y-coordinates, so you just put x equals 0 here. So maybe we should just do it the way the question seems to be directing us. X equals 0 then gives, so let's follow that then. We'll end up with y squared minus 4y, and then move the 12 over to be with it, minus 12 equals 0. Now let's factorize. So 6 2's, and it's 6 and 2, minus and a plus. So that tells us that y is equal to minus 2 and also 6. So those are the two crossing points. And the y values. So find the radius of the circle. Now here I'd like to write it in standard form here. So x squared plus y squared, x squared plus y squared, plus 6x minus 4y. Yep, that's what we got, equals 12. And now I'm going to write it in standard form then. So here half of 6 is 3, so we can write x plus 3 squared. And then the y, half of this is minus 2, so write y minus 2 squared. Now this will produce a 9, so put a minus 9. And this will produce a 4, so put a minus 4, and that will equal 12. Okay, so we see that x plus 3 squared plus y minus 2 squared. I move this minus 13 over to be plus 13, and it will equal 25. So a 9 came out, and we had to put a minus 9, so that we just got left with these two terms. A 4 comes out from the expansion of this bracket, and that's why we put a minus 4, so that we're just left with these two terms. We have the 12 here, and then we moved the minus 13 over to be plus 13 to make 25. So now the radius we can read off on part B. Radius is equal to the square root of this value, which equals 5. Okay. P25 lies outside the circle. Find the length of PC as root n. So P25 then lies outside the circle. So PC is equal to square root. The centre is at minus 3 and 2, isn't it? So use Pythag. The difference in the y's, difference in the x's then. 2 minus minus 3 is 5, so that's squared. And then the difference in the y's, 5 to 2 is 3. So we can do 3 squared. So we get the square root of 25 and 9 is square root of 34. Okay, good. So that's length PC. Q is on the circle, so that PQ is a tangent. Find the length PQ. PQ is a tangent. Find the length of PQ. So you got a circle here. Suppose P is here, say, just suppose, 2 and 5. Here's C. And then we've got Q is on the circle, so that Q is a tangent. So this is a tangent here, and that's Q. C is minus 3, 2. And there's Q. So find the length. So this length here we said was the square root of 34. This is a radius, so this is a length 5. So length PQ then, using Pythag, it'll be the square root of the difference between this squared is 34. Take away this squared is 25. which equals 34 take 25 is 9, so it's the square root of 9, which equals 3. Okay, it was tangent, so that's why that was a right angle to the radius in the center. PQ was a tangent, and that was a right angled triangle. And we just used Pythag there, didn't we, to get this side here. This squared, take away this squared, is here, and then square root that answer, and we get 3. So we've found the length PQ.